So welcome. Unusual for me to be in a hardware track. Don't know an awful lot about hardware. I start by admitting that. And for most of the last 20 years, I've avoided talking about AI because I think you have to be a deep expert to talk about AI, and I'm not. I know a bit about software. And for anybody that I haven't met or who wasn't in the plenaries this morning, I'm Amanda. I'm the CEO of Open UK. Ex-lawyer, and I've worked in the software sector for 20 odd years on and off. You probably don't know I spent a year as general counsel, the head lawyer in a data center company. So although I don't know anything about hardware really, I have got a little bit of knowledge on data centers. And we have had, this is one of the sessions. You know, when you have a conference, there's always a session that's like the jinx session that people just keep dropping out of. So this has been like a revolving door of who was going to be joining me today. But I think it's quite an important topic, so I was really keen to make sure we had it. So I now have three lovely panelists joining me. I have Robbie Jerome from Red Hat. I have Dan Scarborough from Stelia. And I have Sam Johnson. I don't know where you're from, actually. What do I label you as?
Well, let's say here I'm convening the Open Source Alliance.
Okay, so you're here on behalf of the Open Source Alliance. I'm not going to comment on the fact that I didn't know where you were from. Okay. What we're going to do is try and open this up a bit. So we will start by giving each of the speakers a short introduction. Robbie wasn't aware of that, so I'm going to come to Robbie last. I'm going to give you sort of 3 or 4 minutes to tell me who you are, what you do, how you're involved in hardware and infrastructure or your engagement with that, so that we understand a bit of context. And then we're going to have a bit of a general discussion between the 4 of us and open it up to the floor. And we're going to do that because the hardware and data centers, if you are at all interested in data centers or in the environment, you can't have helped but seen in the last few months a strategic shift in data centers caused by AI. And we've seen the UK government, the UK public sector, recategorize data centers back in September as critical national infrastructure. And that's a huge, huge thing, right? And they were talking about opening up the green belt, the capacity of data centers. Some of you will have seen Microsoft and AWS talk about moving to nuclear power. So just getting these data centers built, getting them the energy they need, managing that infrastructure is absolutely huge right now. And we've done a few things on policy and data centers with an event at the Labour Party conference in September. We've done an event in the House of Lords that Robbie was at and one of Dan's colleagues. So we've been doing quite a lot to raise awareness and to talk about how we can open some of that up, but also to understand what this infrastructure need is. And I suppose for me, I was a lawyer back in the dot-com boom, and in the early 2000s, we had this massive scaling up around the internet beginning to happen. But a lot of the technology didn't really come to fruition. It didn't really get used, and it didn't get used because we were working on twisted copper pair. We didn't have proper internet. We didn't have proper connectivity available to us. And that meant that the scale of innovation was much slower than it could have been. So I know when people today say to me that you're going to lose your job to AI, well, maybe I will. But if you're going to lose your job to AI, it's not going to be as fast as everybody expects because we don't have the data center capacity to process the compute. So I'm going to come over first to Dan, who probably is the person who knew most that I was going to do that. So Dan, can you give us 3 or 4 minutes just about what you do in this infrastructure space?
Okay. So I had the privilege of being with Amanda at the Labour conference the back end of last year. And we did a panel on the data center industry in the UK and how it's evolving and how it compares to the global market. I'm not a software, I understand software and hardware to a limited extent, but I've spent my entire career working in how you design, build and operate data centers. And I've seen them kind of transition from the late 90s to being very enterprise dominant assets that were very highly engineered to ensure that there was no failure at a hardware level, all the way through to the kind of move towards hyperscale cloud computing that you've seen over the last 10 to 15 years, where, you know, a large transaction has gone from being 5 megawatts to 100 megawatts. And then over the last 24 months, that's been changed on its head against with the kind of introduction of NVIDIA GPUs. And that's had a material impact on the data center industry in terms of its traditional operators, because most data centers have historically been used to running a lot lower density at a rack level. And these GPUs require a lot more power and give off...
Can I interrupt you? So in this room, how many people understand this conversation at that level?
Excellent.
Yeah, you're all right. I was just going to make sure if we had to explain GPUs. You're fine.
Excellent. And so we've witnessed that transition. So the company that I am so my background's in data centers. I set up a company called Data Center Dynamics in the late 90s. I've consulted for people about how to build, design, operate, find site selection, everything that you could possibly do within data centers I've done. I also got involved very heavily in the crypto space within blockchain and Web3. And I've started to see a convergence between tier one infrastructure with the ex-Ethereum miners that are moving in towards deploying GPUs and the data centers, which is quite exciting, really, because I think it's going to make both of the markets more efficient. But the business that I'm in now, Stellia, we concentrate on how you connect these assets together. So at the minute, most of the data that is transported in and out of these GPU clusters goes over the internet. So we've got a hyperscale interconnect platform without the compute, which is based on hyperscale technology, and we allow GPU clusters to communicate much more effectively. And what we're seeing is that what people are doing at the moment is just sticking hardware in rooms or hardware in buildings, right, at whatever scale they can get. If they can get a gigawatt, they stick it in a gigawatt. If they get 5 megawatts, they stick it in that type of capacity. What hasn't yet happened, and what we're seeing happening or hoping is going to happen, is that they have to connect it all up, and it becomes more of a ubiquitous resource that anyone can consume. And that's what we're working on. So we're working on not only connecting GPU clusters together more efficiently than traditional MPLS networks, but we're also working on how you can integrate more with kind of enterprise applications to allow them to consume non-hyperscale resource. Because at the moment, a lot of the model builders that are out there and a lot of the people that are consuming the GPU resource are heavily reliant on the traditional large-scale hyperscalers. And there is a lot of resource that's been built out by NVIDIA cloud partners, but a lot of that is just sold as bare metal to single cluster customers. So we're building a middleware layer where all of this resource is connected to us. We've got enterprise integrations that allow them to consume GPU across other clusters than traditional hyperscale clusters. So that's my background.
So I'm going to come over to Sam. Abby, there's no clock. I don't know what time it is or what my countdown is, so if somebody could pass me a clock, that'd be brilliant. Sam, well, I don't have a clock. It's 3 or 4 minutes. I've got a rough clock in my head.
Okay, so Sam Johnston. I am fortunate to be able to donate my time at the moment to a 501c3 called Quai, an open source AI lab, where I'm the lead developer of a thing called the Personal AI Operating System. So looking at how do we have applications and deploy them onto whatever hardware happens to be in front of us. And we had a good discussion at the AI Plumbers Convention. It kind of sounds like the Basket Weavers Association, a bit weird, but this is following on from FOSDEM on Monday about like, okay, I've got this application and now it's got this PC or this server, and like, is there an NVIDIA chip in it, or is there some other, like some of the new, more open hardware and so on. My exposure to infrastructure is from spending some time at Google, where I was backing it up to tape. So half a dozen exabytes of data going on to 1 million tapes and various robots and trucks and different things like that. So I had the good fortune to be able to visit all of Google's owned data centers at the time. Through them I met Equinix. I went to Equinix as the Director of Cloud and IT Services. I commuted here to London for 5 years and introduced things like the Cloud Exchange to be able to connect directly from enterprises into cloud.
And today, what are you doing that engages with all of this in the AI context?
Well, the reason I'm here really is about looking at what does open mean at a high level, and then the different components in these systems, from hardware to software kind of code to data to AI models, and specifically what is open source AI.
Right, so you're looking at the big picture. Robbie. So let me work it out. You mine.
There we go, that's better. Good afternoon. So I'm Robbie Jerram. I'm a principal technologist at Red Hat, where I focus on AI. And I guess I kind of sit between the software application layer and the data centers and hardware. So that virtualization tier, that container tier, that place where the models run before they consume all of the power that's provided nicely by Dan's data centers. So I focus on building models, putting models in production, and scaling those up across data centers. Prior to Red Hat, I was at VMware for 12 years doing a similar thing on NVIDIA hardware specifically. But now it's more around open hardware, open GPUs, and of course, open source AI models. So that's the absolute focus, is how do we run these things more efficiently, because they use a tremendous amount of power, and how do we make them available to as many people as we possibly can.
So where do you want to start? Will we start with the actual infrastructure challenge? Will we start with the availability? Or will we start with power? Any preferences? Right. In that case, we'll go for the infrastructure. So I'm told that we have a massive challenge, that the infrastructure isn't there to connect us from A to Z. Is that right? And how do we fix it?
Yes, I think there's a lot of different things that are going on and happening very quickly, right? And as I was saying to one of the co-panelists, from an AI perspective, we're kind of in the dial-up modem phase, if you like. So we're back in 1996, where we've just got access to the internet. You go and make a cup of coffee and come back, and it's still not loaded. And fast forward 20 or nearly 30 years, God blimey, things are very different now, right? So I think if you look at AI in the context of what's going to happen over that period of time, we were with NVIDIA 2 weeks ago with an EBC in San Jose, and they're currently building out 350,000 GPUs in 100 data centers, right? Which is an absolutely ridiculous amount of capacity. And they are all being used by this arms race of the model builders to currently create larger and larger models. Most of if you ask anyone from any of these organizations about, are enterprise using AI yet? They kind of look at you with this face saying, well, not sure yet. Is inferencing happening yet? Inferencing isn't. So we really are at the early stages. The release cycle of NVIDIA's chipset has been kind of creating somewhat of an issue in the market. The capital that they cost and not being able to amortize that asset for any longer than 12 months before you've got another release cycle. They've also been screwing around with when they come out and how they come out and what the design is for them. When you're building a data center, traditionally you build it over a 36-month period. The people that have been coming out with and buying these GPU assets over the last 24 months want the asset in 3 months. They want a data center in 3 months. And they don't just want 1 megawatt; they want 30 megawatts, or they want 60 megawatts. And that's.
So is it happening? Is that being delivered?
So you've got a next generation of data center operators that have developed out of platforms like Equinix and some of the more traditional platforms that have seen this as an opportunity and have got very well funded and are starting to build things in a more of a modular manner. The only way that you can really deploy that type of infrastructure at that speed is if it's in a brownfield site or in an existing facility. You've got the added complication that you're now looking at standardization on DLC, so direct to chip, to try and support the rack densities. Data centers historically have been built to last 15 years, and you're going from a kind of 40 kilowatts to forecast half a megawatt rack density over the course of the next few iterations of the chipset. So the data center operators are thinking, oh my God, how's my data center going to cope with this transformation at an infrastructure level? You've also got the kind of the thought process that they're signing up for 10-year contracts. They're having to kind of, they've got 2-year contracts if they're lucky on the GPU asset. So the model builders that they're leasing this capacity to for 2 years, they've got a 10-year data center contract, and they've got to amortize this hardware asset over a 5-year period. The funders are starting to worry a little bit because they're overexposed to these types of infrastructure investments. So everyone's looking at how can AI be consumed more ubiquitously. So how can it be, how can it really do what it's set out to do? We're not talking about chatbots. We're not talking about a few words in and a page out. We're talking about, AI for the good of what AI can do. And I think that's where things like open really come into it, because the only way that you can really change the way that software is developed, we've seen historically over the last few decades, is by bringing it into open source. And that's why I'm really excited about what you've got to say here. Just quickly, the internet is pretty screwed as well. The internet wasn't designed to to deal with the volumes of data that it currently carries. So having new transport protocols, having new ways of moving the petabits of data around and between these GPU clusters is where Stellia is focused on, and other organisations like us.
I was just about to ask you to come in, and you picked up your mic before anyway, but it makes me think of South Park. You know that episode of South Park where somebody pulls the plug and it takes them days to work out that somebody's pulled the internet out? It kind of feels like we're living in that. How are we going to actually get this to work?
Yeah, look, I was just you're going to drill down a bit on those, on the kind of orders of magnitude we're talking about here. I mean, coming from enterprise, you're talking about like 1 to 2 to maybe 4 kilowatts per rack, right? We would deliver kind of, and I left Equinix, 10 years ago now, this year, we were delivering like 10 to 40 kilowatts per rack, and not many people were asking for 40, right? And when you got up to that, you'd end up with kind of one rack in the middle of the data hall, and then the rest of it's all stranded space, right? We talk about stranded space and power, but now you're talking about like half a megawatt, like going into one rack, right?
Yeah, I think so. So HPC traditionally has been, operating at that. I mean, Cray computers, were liquid cooled and high performance. I think the difference between AI is it's much more about how fast you get data on and off of it. So it's the backplane of the new GB200 is I think it's a 137 terabit backplane, right? And if you plug that into an external network that's got 100 gig IP access connected to it, it kind of doesn't really work properly. You've also got the limitations of NVLink, which is the InfiniBand network protocol that allows you to go between 150 meters. And what that means is that you can no longer spread it out. So you can't any longer have a big football pitch with racks all over the place, because these things operate as one unit, so they have to be very concentrated. I mean, if you come from an MEP perspective, which is mechanical, electrical, plumbing, they call it, how you build data centers, and you speak to someone about half a megawatt rack, they just laugh at you, right? But I have seen designs for 10 megawatt rows. But then what it becomes is, at the moment, if you go to a traditional data center, probably 70% of the space is white space, which is where they put the racks, and 30% is supporting kind of mechanical, electrical infrastructure. With these new megawatt racks, it's like 99% is infrastructure. And then there's
nuclear power station, right, with a little.
And it's just not sustainable. I mean, one of the things that we're seeing is becoming a bit more innovative is, kind of where they're being located. So there's a lot of work with power companies like Deep Green, who couldn't be here today, have just been bought by Octopus. They're looking at heating swimming pools with this stuff. You've got another company called T-Loop who are doing stuff with decentralized heating plants as well. You've got a company called Edgevana, who are Edge Nebula, Edge something or another, who are using office buildings. So the answer isn't to go out and find a gigawatt campus or a gigawatt worth of power and stick a load of racks there. And until we can integrate it more into the rest of society, we're going to be challenged.
So you're saying that's not the answer. So the answer is to bring something closer to the end user.
Well, I mean, ultimately, what is in the last year, so if you go back 2.5 years ago, maybe 2 years ago, data centers were concentrated in metro areas. So you had traditional Frankfurt, London, Amsterdam, Paris were the key markets. Secondary markets were, Milan, Madrid, and the other markets. What's happened in the last year and a half is everyone's just gone to where the power is. So, they're not really thinking about how the data gets back. They're just building sheds next to power plants and trying to deploy GPUs there. And the biggest challenge with all of it is that what you'll find is that the people that are deploying the GPUs are not using the GPUs. So these neo cloud providers that are leasing or buying these assets and then leasing them to a model builder, the model builder are the ones that have to make them work and have to get the data on and off of them. And they're not being designed for the consumer and the user experience. And that's part of the challenge.
Robbie, user experience, thoughts?
It's all about the user experience. And the model, as you say, the model builders are focused on how do we get the data onto the GPU as fast as possible, build my model, get it out there, doing something with it. And I was wondering whether that latency decides their placement to a certain extent.
So you would have thought it would do, right? But they don't really, the specifications that they're putting into the deployments are diverse 100 gig links. And the reason being that that's kind of what is available in the market right now. So we've got 1.6T that we're trialing. We've got 800 natively across our platform. I think the iterations of network capacities are going up. But part of the challenge that you've got is that the traditional network providers who we're trying to support and work with, they're not moving as fast as the cloud. So if you take kind of traditional MPLS networks, BT and all the network providers that run the dark fiber and connect into all these data centers, if we're in the age of the dial-up modem right now from an AI perspective, they're probably in the age of the invention of paper. Do you know what I mean? And it's kind of trying to get their technology upgraded to the point where everything runs over fiber. You need the fiber in the ground, but how efficiently it's used and how you can, what you stick at each end of it and the throughput can be a lot better with Broadcom-based silicon technology.
So I'm going to bring it out to the audience because we haven't got very long left based on the clocks that I'm seeing. Does anybody want to join the conversation? Any questions, comments? Rob? Oh, you want a microphone? You have mine. Yeah.
Yeah, it's one of those things, like, it always seems like the sensible option is that we have house heating being provided by compute. Do you have any thoughts on that and what the limitations and problems are?
Yeah, so you're seeing that. So there are immersion cooling is considered to be one of the form factors. There are a number of operators in Singapore that are delivering GPUs with immersion. There's an operator in Australia that have now got them in office buildings. There's one that's trying to do the same over here. But in fact, there was someone that was trying to do it at domestic level. I think it's a bit the problem is because of the cost of the assets. And it's a bit like a Bitcoin mining machine, right? People are talking about using it for non-consistent power, but because of the cost of the underlying machine, unless you're using it all the time, unless you're optimizing the use of it, it's just not financially viable. So as the cost comes down, and that's where these other silicon providers come in, and things like Cerebras and all of the other silicon operators that have got different options from a GPU perspective. At the minute, it's quite monopolistic. The pricing is set to drive shareholder value for one particular customer, and that's considered now the benchmark. How well do we perform compared to an H100, where it really shouldn't be the benchmark? It should be how well can we deliver this job for our customer. So it should be much more outcome focused from a usage perspective as opposed to GPU performance.
So I'm very quickly, there's two questions, and before we have to wrap up, I'm going to take the two questions and then get the answers. Nick?
The other thing is houses don't need to be heated all year, right? So that's a challenge.
So there's a French company called Carnot that will sell you, with a Q at the start, that will sell you what looks like a radiator. It's like a thick radiator, and behind the radiator is a computer. When you turn it on, it distributes workload, and then it heats your house up. It's actually been around for a few years. That wasn't my question. I was going to ask a few questions about sustainability, because I work for an AI neocloud provider. One of our first data centres is in a very remote part of Norway. It's right next to a hydroelectric power dam. A lot of these great sources of sustainable energy exist in places which are terrible from a connectivity perspective, from a physical connectivity perspective. I don't know if that's something that you can speak to.
Yeah, who do you work for?
Nscale.
Okay.
So I'm going to take this last question because we're just about out of time, so we've got both questions to try and answer in one go. There you go. I know you're waiting.
Yes. So we actually built infrastructure in apartment complexes. So a startup in Singapore is giving hot showers to elderly in an apartment complex somewhere. Massive GPUs there. That's not my question. My question is, as far as I've seen in Europe, who will actually buy those gigawatt capacity AI training centers? Because I haven't found them in Europe. I think they're in China. I think they're in US. But here in Europe, there's not that much training companies out there.
Okay. So
We've literally got 3 minutes before I'm going to
so-
get chucked out of here, I think.
So there's
10.
a lot of
Okay, we've got 10 minutes, that's all right, we can chill.
So there isn't as I reckon Europe is probably a tenth of North America in terms of total GPU deployment. You are seeing multiple 100-megawatt sites, especially in places like Norway. You do have companies like Nscale that are deploying large amounts of capacity for third-party customers. And there is going to be an increasing amount that's going to come into Europe. But we're not doing any of the, I think America's big as, whatever Trump says, it's a lot bigger over there, right? In terms of the market in Norway and places like that, we've got a high-capacity fibre ring in Norway. And Norway is a great market. It's got a ton of renewable energy, but the fibre is completely shocking. So, we're deploying fibre up into the north of Norway. They micro-bore it as well. So in terms of in the cities of the UK, they lay big pipes with tons of fibre. In Norway, they put 6 strands in. So the amount of fibre that's supporting this underlying power infrastructure is not sufficient. But we're working on that. And, I think, ultimately, it's probably not going to be a problem anymore because Norway is producing a big power line to export more power out of its country to places where they've got more fibre anyway. Do you know what I mean?
The good news as well is that depending on the application architecture, quite often you do need to have kind of this data gravity concept, right? So especially if you're building RAG architectures for enterprise, you want to have that enterprise data near to where the inference is being done. But from an end user perspective, you're sending a small prompt and getting a relatively small answer back. So they can be kind of tens of milliseconds away. Ideally, it would be closer probably to the center of Europe, but yeah.
I mean, the milliseconds, I think, we've got half the number of the distance round trip time period to Norway is through a traditional MPLS network. We can cut that in half, if not more than half.
Can I get you to speak to the mic? Sorry.
It sort of depends on what it is that you're trying to serve and where you are in terms of your AI lifecycle. Like for inferencing, latency is a bit more sensitive to the end user experience. Training, it's all about throughput. It's all about that bandwidth and how much data you can transfer between sites.
Yeah, I mean, what we're seeing is that you can increase the ROI performance on the asset by at least 10% because you can get it on, like the occupancy rate that you're seeing for these assets. Originally, they were forecasting them at 80% occupancy. You're lucky if you're at 40% occupancy. And if you've got a much higher capacity coming onto them and off of them, you can increase that occupancy, which makes the value of the asset higher and pays for itself. But again, a lot of the clusters that you're looking at in Norway are single-tenant clusters for single clients. And so it hasn't become a ubiquitous computing. And what the challenge is that once that contract ends, say you've got a 2-year contract with a particular hyperscaler, at the end of that 2-year period, how do you use the compute? So we've got clients that have got 13 deployments in North America, all with separate different contracts. None of them are connected together. And they're really concerned that at the end of those 2-3 years, how they're going to monetize the asset afterwards is more of the challenge that we're trying to solve.
But isn't that the same in every bubble, every new drive, that it takes a bit of time for it all to settle down?
Yes, 100%. And it's going to, you're already seeing that, the current changes that you're seeing in the market, dropping of the share prices, DeepSeek stuff that's come out. But it doesn't mean that, it's not, the bubbles aren't going to burst in the same way that they burst before.
So I think from the software stack perspective that's driving the infrastructure, to the .com example, right? We saw the growth of websites and everything, and everyone was pushing everything as quickly as we can. We're seeing that with custom models at the moment, and everyone wants to build their own models, train their own stuff. But as we get more comfortable with RAG architectures and having AI infused across all of the application stacks, we're going to start to see that leveling off, and it just becomes that sort of, this is how we run these things. The size of the models are going to come down. DeepSeek's a good example of that efficiency. Is that's going to drive a different behavior pattern for the data center architectures, or are we just going to keep seeing it growing and growing? I mean, I like to think it's going to be more efficient through software, but I'm perhaps a little biased.
I think as it becomes more of a utility, at the minute it's been a build it, lease it, build it, lease it, build it, lease it, right? A guy that I was talking to the other day was anticipating that 50% of the neo clouds, who are this next generation of cloud providers, are building capacity for hyperscalers anyway. So it's a lot of that capacity is for hyperscalers. But as it becomes more of a utility and people start consuming it, and you get this middle, what we're missing at the minute is a middle layer. So enterprise are not going to consume AI without a Google, a next iteration of companies that's going to enable them to consume AI. So you've got like different companies that are filling that gap and helping you to, like if you, for instance, from a building perspective, if you were to take all the data feeds out of this building and then you were able to use that data feed and model that data to make the building more efficient, that's not going to be done by the building, it's going to be done by a third-party company. So as these AI startups that are funded, thousands of them, start maturing and start bringing products on that enterprise can use, hopefully that will take the slack of that GPU resource and it will become more of a kind of a ubiquitous resource that people are using as we get into the fiber as opposed to dial-up modem stage.
Kind of get into that AI-infused operating system, the enhancing Linux or whatever that's going to be.
It's like if you look at your iPhone. Sorry.
Yeah, so I'm just, a lot of what you're talking about with the rollout and the way in which the network is kind of falling behind, are we not running the risk of being very short-sighted about the current bubble of AI and over-deploying? Because like the time it takes us to build networks, like I'm involved in network building, right? Like my company writes software for this stuff. And I've worked in data centers as well, and the time scale that we're talking about for build out isn't not optimized for these bubbles, right? And the collapse is coming. We can see that with
so I think one of the things
whatever it's called.
So one of the things that we're seeing is that we're working quite closely with the underlying fiber. The underlying infrastructure is fine. So we're not talking about replacing the underlying fiber. It's about what rides over it and what you use on it. So we're doing a lot of stuff with telcos who have got huge amounts of fiber assets, but they can't monetize them to any further extent. And they can't adopt new technology because like Zayo's got, 40 different networks that they've patched together. So trying to upgrade 40 different networks is very difficult. So we're trying to educate the underlying fiber assets are great. More or less, it's what they're doing with them is the issue. But one thing I would agree is, yes, it's all, why are we doing what we're doing currently? It does strike me as being a gold rush, and, the people that are going to make the money are the people that are providing the tins.
There was a question before, right, about the gigawatt scale kind of AI factories, right? And so, for risk of being on a bit of a hot topic here, right, is like going and standing in line behind Sam and Elon and so on for getting, to get kind of the end of the last generation of chips and deploy them. We heard that they've got a lifetime of 12 months, right? Might take you 6 months to deploy them, so you've got 6 months left. And then a lot of the topics we're coming on here to kind of go back to when we were talking about cloud computing, which is 15 years ago, and you're talking about utility and this like transition from product to service. Well, the AI factories are kind of a community cloud. We're talking about building like private clouds for enterprises, but what seems to be missing from what I heard from you before is like this kind of true multi-tenant, like lower level, being able to deploy an AI application onto virtual hardware, right, which is your area.
Yeah, so you see if you speak to some of the model builders and you look at the older models, right? We were saying this earlier. You can't press a button and upgrade all the older models, right? So you have to try and all these older models are still on the new hardware. So there's
That's fascinating. I didn't know that until today.
So trying to get those older models on older hardware, trying to segment the market a little bit more. How all of this capacity is consumed currently is via the model builders. And people that I've spoken to would say they're probably not doing it as efficiently as they could do because they really like it and they get excited like you do. You know, new iPhone, I want a new iPhone. So there's a whole consumption patterns that has to come out, and that has to be driven by the economics and the finance and the performance of the business. And as we were saying earlier, a lot of these model builders, their value is in equity. So their equity value businesses, their income that they're generating is not delivering against the value that they're charged for delivering what they're delivering, and that has to even out somehow. That economic model has to change.
Wait, I'm sorry. We're just about, I think I have less than a minute. Yeah. So I'm going to come to each of the three panelists and give you 20 seconds each, split my last minute between you. 20 seconds, parting words for the audience, wisdom on infrastructure and AI.
Look, I think a lot of the AI applications are really bound quite tightly to whatever hardware they're deployed on. So if you like deploy onto a TPU at Google, then you get a blob that's kind of tied to the TPUs. If you write to CUDA, then you're really stuck on CUDA. And this is one of the things that DeepSeek did, is they went like to assembly level. And so there's some really, really interesting hardware and open hardware projects that I think really need some attention and love and investment.
Robbie.
You stole what I was going to say. I mean, it brings us to open source AI ultimately, right? I mean, that ability to abstract away from whatever framework that the model's being built on and be able to deploy it on any tin from any GPU provider and have those optimizations, be that sparsification of the model, efficiency of the model, or even placement approach of the model requiring some operating system stuff. That optimization layer we can only do in open source because we need to be able to go across all vendors, across all platforms, and across all model builders. And we're not quite there yet.
Dan.
Yeah, so if you look at what Linux did to the old data center and the licensing model that they did, right, they completely removed the licensing model from the data center. And hopefully over the course of the next couple of years, as OpenAI and open source development reaches that maturity level, it will be able to do the same, and it will be able to completely optimize the underlying infrastructure stack that everyone's using. Thank you very much.
Panelists, thank you very much. Audience, thank you for your questions.
Thank you.
Just a reminder, in case you haven't had anybody tell you, 5:30, drinks tokens available from reception desk, booth crawl 6 till 7:30, prizes at 7 for the booth crawl. So I hope to see you all in the drinks later, and thank you for joining us.